Hello everyone, welcome to the GCSE Chemistry revision course. I'm going to be your tutor for the rest of the week, and yeah, I'm really excited to get it started. So I'm Velina and I study chemistry at the University of Durham. So today we're going to be covering chemical equations and separating mixtures, but quickly before that, let me run you through a bit of info about today's lesson. So it's going to be 1 hour long. It's going to be recorded, and these recordings will be sent to your parents via email. So if you have any questions throughout the session, please send them through on the chat and they'll be answered. I'll look through it after covering each topic and hopefully go through them after topic. So today's lesson obviously was at 6 p.m, but for the rest of the week, the lessons will be from 5 till 6 p.m. So yeah, tomorrow's lesson will be 5 till 6. So today we're going to be covering chemical equations and separating mixtures, and start by covering a bit of background information on atomic structure, which is very fundamental in chemistry. Tomorrow's lesson, we're going to focus on some other separating techniques, specifically paper chromatography and also fractional distillation. And then we're going to finish with looking at the noble gas, also covering a little bit of basic electronic structure. Then on Wednesday, we're going to look at our group 1 and group 7 and the trends down those groups. On Thursday, we're going to cover the transition metals and then do a little summary of everything we've covered over the 4 days. And on the 5th day, on Friday, our last day, we're going to look into exam techniques and then try answer some exam questions that are on the topics that we have covered this week. Okay, so if anyone will just start by looking at the atom. So what is the atom? So atoms are very small particles that make up all substances. Okay, sorry, I've just seen a question. We will be doing the Kahoot at the end. Yes, there's going to be a Kahoot once we've finished this content. Okay, so the atom is made up of protons, neutrons, and electrons, as you can see on this diagram. So at the center of the atom, we have this thing called the nucleus. And within the nucleus, you can find your protons and your neutrons, okay? Around the nucleus, you can see electrons that orbit the nucleus, and they just are on the outside. Okay, so we have our protons and our neutrons, and each of them have a relative mass of 1. However, our electrons are much smaller particles. You can think of them as having a mass of 0, but if you want to be more specific, it's a relative mass of 1 over 2,000, as you can read in the bottom bit of this table. So those are your properties, some of your properties of your protons and your neutrons and electrons. Another thing to note is the relative charge of these things. So your proton has a positive charge, and a way to remember this charge is to think P for positive. Okay, your neutron, as the name would suggest, neutron sounds a bit like neutral, has a negative, has a charge of 0. Here it says res charge of 0. So think neutral, neutron, no charge. Okay, and then lastly we have our electrons that are orbiting around. As we can see, they have a negative charge, which is just something might be tricky to remember. Okay, so protons positive, electrons negative, neutrons 0, and protons and neutrons have a relative mass of 1, and electrons are tiny. They both have a relative mass of 0. Therefore, the mass of the atom is very much in the nucleus at the center of the atom. Okay, so let's talk a bit about the periodic table. So this is where all the atoms are arranged. So you might have seen this line at school, and on this side of the line are non-metals, okay? Whilst on this side are the metals. That's really important later on when you start thinking about bonding and how different species will bond. So another thing to remember about the atom is what is an element, okay? So in the periodic table, it's all elements. There are a list of elements. So all an element is, it is a species that contains just one kind of atom. So if you have O2, for example, just your simple oxygen, although it's got two oxygen atoms, it's just an oxygen atom. There's just one type of atom, and therefore it is an element. So whenever you have one type of atom, it's an element. However, if you take water, for example, you will see that there are two elements present, right? So therefore, this is no longer an element, as with an element, we only have the one atom present. So this is called a compound, as you have more than one element in it. Okay, so now let's think about the periodic table bit. So here you have this key, right? What does it mean? So at the bottom, it tells us, well, the key tells us exactly what each part of this symbol, this representation means. So at the bottom, it tells us that we have our atomic number, and in brackets, proton number. So this is quite self-explanatory. That atomic number tells us the number of protons that we have in our atom, which is found, and the protons are found in our nucleus. So the atoms in the periodic table are actually arranged in increasing order of atomic number. As you can see, 1, 2, 3, 4, 5, 6. So you just like increase the atomic number by 1, going consecutively across the periodic table. So the top number, as we can see on a lot of cases, not necessarily hydrogen, sorry, but the top number is greater than the atomic number, the bottom number. So what the relative atomic mass is telling us is the number of protons and neutrons in our nucleus, okay? So because your proton and your neutron have a relative atomic mass of 1, having a relative atomic mass of 4 means you have 4 protons and 4 neutrons in your nucleus, okay? So this allows us, knowing this, allows us to figure out how many neutrons we have in our atom. So let's take our helium as an example. From this symbol, we can see that our atomic number is going to be 2, and our relative atomic mass is 4. So this has told us how many protons we have, and this has told us how many protons and neutrons we've had. So therefore, how many neutrons do we have? All we do is the relative atomic mass, take away the proton number, so 4 take away 2, which is equal to 2. So that tells us that we have 2 neutrons, okay? So things to remember, proton number is the number of protons, which is the bottom number. Top number is relative atomic mass, which is just the number of protons and the neutrons in our atom. Okay, so another thing to think about is what will be the number of electrons, okay? So previously we learned that the charge of proton was positive and the charge of electron was negative, okay? And another thing to note is that all atoms in the periodic table are going to be neutral. So therefore, their positive charge and their negative charge must cancel and be equal to 0, okay? So for the atoms to be neutral, we need to have the same positive and the same number of negative charges. So let's look at helium again. We know we have 2 protons, so each proton brings a positive charge. Therefore, we need to have 2 electrons so that the 2 charges cancel out and are equal to 0. Okay, so this is true for everything. So if we take nitrogen, for example, we can see there are 7 protons in our structure, in our atom. So that gives us that's a 7+ charge. So therefore, we need 7 electrons. That gives us a 7- charge. Okay, so that's a summary of your atomic structure and your periodic table. So I'll look at some questions if there's a couple of questions are coming through. So the exam boards are quite general. So this is like based more sort of off the AQA syllabus, but it covers the content of just chemistry, GCSE in general. This is like important to know for all different exam boards. And then, so what this staircase line is showing you is non-metals that are this side of it, and then you have your metals on the other side. Okay, so this whole side is metals. Although, yes, you do have your transition metals, that is the middle part, as I think someone has mentioned. So this middle part is your transition metals, but that is still a metal, so therefore they do still count as metals. Yeah, so someone's asked if the atomic number tells you the amount of electrons. Exactly. So the atomic number, also known as the proton number, is equal to the number of electrons as well. So people, the common question is, why do we do 4 minus 2 for the helium atom? So as we said, 4 is the relative atomic mass. So that is both the number of neutrons and protons in our nucleus, okay? So the relative atomic mass is always the number of protons and neutrons, and that's always the top number. The bottom number is the number of protons. So then if we want to find out the number of neutrons, we must do 4, because that's the number of p plus n, p and n's in the nucleus. And then our 2 is just the number of protons. So therefore 4 take away 2 is going to equal the number of neutrons. So this calculation, the relative atomic mass, so the big number take away the small number, is just your number of neutrons. Now we can practice this a bit here. Okay, so we have, in this case, in oxygen, right? The top number is 16. This is our relative atomic mass. So this is the number of protons and neutrons. The bottom number is 8, which is the number of protons, okay? So now if I ask you, what is the number of protons and what is the number of neutrons, sorry, all we're going to do is 16 take away 8. Therefore, the number of neutrons we have is 8, okay? So now if we look at phosphorus, what is the number of protons? It's going to be 15, right? And what is the number of protons and neutrons together? It's going to be 31, as this is the mass number. So therefore, if we want to just find out the number of neutrons we're going to have, we're going to do 31 take away 15, which is equal to 16. And that's the number of neutrons that we're going to have. Later on, when we do our Kahoot, you're all going to have a chance to practice and answer a couple of questions on this, which will be very fun. Okay, let me just check any other question. Yeah, perfect. I can see some of you guys are answering. Brilliant. Do you guys want to write in an answer for C then? If people want to jot down an answer for C in the chat. Yeah, brilliant. I can see lots of correct answers. Well done, guys. Okay, perfect. Well done. Okay, so now we're going to move on to chemical equations. So what do chemical equations tell us? They tell us about how a reactant goes to form a product. So you have 2 types of chemical equations, and well, something to remember is that on the left-hand side, you will always have your reactants, and on the right hand, it is always your products. One type of chemical equation is your word equation, like here, hydrogen and oxygen make water, right? But this sometimes isn't very useful, as it's quite nice to see how many atoms you have in your equation. And this is shown through the symbol equation as seen on the bottom. So with chemical equations, this is, sorry, that one's just fix up a bit. So with chemical equations, it's really important to have So this kind of equation is called a symbol equation, right? You're using your symbols from your periodic table. So with the symbol equation, you can see if your equation is balanced. So what is a balanced equation? It means that you have the same number of atoms on the left-hand side as you do on the right-hand side. And these two sides must always be equal. Okay, so your left side must always be equal to the right due to the laws of conservation. You can't ever have different numbers of atoms on the left and on the right. So what does this mean? Okay, if we get rid of what I wrote down, we can run through an example. So that was a balanced equation. Currently, this is not a balanced equation, and our laws of conservation are not kept. So how many hydrogens do we have on our left-hand side? We can see it is 2. How many oxygens do we have on our left-hand side? We can see it is also 2. But how many oxygens do we have on our right-hand side? We have 1. How many hydrogens do we have? We do have 2. So we can see our hydrogens are balanced. However, our oxygens are not balanced because 2 is not equal to 1. And because all atoms must be the same on either side, the number of atoms must be the same on either side, we must balance this equation. Okay, so let's start here, right? To get from 1 to 2, we're just going to multiply the oxygens by 2. The way we do this is we put a number at the front of the compound. Okay, it's really important because you're not changing the composition of your compound. It's still going to be H2O, but you do need to get 2 oxygens. So therefore, you need 2 of these compounds to make sure you balance this equation. Okay, so we're going to put our 2 in front of here. Yeah, so now we're going to count the atoms on the right-hand side. We're going to fix it. How many hydrogens do we end up with? So 2 times 2, because the 2's here. So in the formula, what this little number is telling you is the number of hydrogens in your formula. Okay? So now, if we put a 2 in front of the water, how many hydrogens will we have? We're going to have 2 times 2, which gives us 4. Yeah? But now how many oxygens do we have? We have 2 times 1, because there's only 1 oxygen in our formula, which is equal to 2. So therefore, these 2 are now balanced. However, the hydrogen is now not happy because we have 4 hydrogens on one side and 2 on the other. Therefore, they are not balanced. Okay? So how can we fix this? How can we get from 2 on this side to 4 like we want? All we need to do is just multiply the hydrogen by 2. This changes our 2 into a 4, and the equation is satisfied. We have 4 hydrogens on the left-hand side, 4 on the right, 2 oxygens on the left, 2 oxygens on the right. So therefore, it is perfect. Okay, we're going to just do some more practice on this topic, on balanced equations. I can quickly look. Are there many parts of this topic? Okay. So a balanced equation means that you have the same number of atoms on your left and on your right. So if we have 4 on this side, we must have 4 on this side, as now we do. That'll be a bit clearer now in this example. I'll just go over it. So let's start with our potassiums. How many potassiums do we have? We have 1 on this side, on the left-hand side, 1 on the right-hand side. How many nitrogens do we have? We have 1 on the left side, 1 on the right side. How many oxygens do we have? We have 3 on the left. However, we have 5 on the right. So therefore, oops, sorry, not 5. We have 4 on the right. Yeah, because can you see, we have 2 oxygens in this formula and then 2 oxygens from here. And we know that it's 2 oxygens because it is O with a little 2. What that means is it's 2 oxygens in the equation. Like if we had H2O, our molecule looks like this. Many of you may have seen this, right? So the little 2 means that in this molecule, we have 2 hydrogens, 1, 2, and just 1 oxygen right here. Yeah? Okay. So what that little 2 means, like we said, it means there's 2 oxygens here, and then there's also 2 oxygens there. So now let's try balance this equation. So we've got 4 on this side. So we're going to have to do something to this side firstly. And we can try with our smallest factor or multiple, which is going to be 2. So if we multiply this side by 2, we're going to have to recalculate how many potassiums, nitrogens, and oxygens we have on our left-hand side. So 2 times of this formula, we have, so if we started off with just 1 potassium, now we're going to have 2 potassiums because we just multiplied by 2. If we start off with 1 nitrogen, we're now going to have 2 nitrogens. And in this formula, we have 3 oxygens, don't we? Because there's a little 3, which tells us how many oxygens we have. So 2 times 3, that gives us 6 oxygens. Is this equation remotely balanced now? No, it's not. So as we can see, now we don't have even these ones balanced. So we need to think, what can we try next? So this one's quite a tricky one, as there's quite a few steps to getting to the final balanced equation. So if we put a 2 in front of this molecule, what are we going to get? So we're going to get 2 potassiums because we only had 1 previously, so 2 times 1 is 2. We're going to get 2 nitrogens, and then from this part, we're going to get 4 oxygens because 2 times 2 oxygens is obviously going to give us 4, right? And from this part, we're also going to have 2 oxygens. So therefore, in total, we're going to have 6 oxygens on this side as well. Yeah? So that means that we are happy with this balanced equation, as we have the same number of potassium, nitrogen, and oxygen molecules, atoms, on either side of our chemical equation. That was quite a tricky one. So the conservation of mass is exactly that, the same number of atoms on both sides, perfect. So you have to always have the same number of atoms either side of your chemical equation. So the difference between metal and the transition metal will be covered later on when we do transition metals on Thursday. Yeah, so these topics are general to both AQA and Excel. They'll be everywhere. So we're going to go to another question on this balancing of equations. So the next one we'll see. Let me just look through these questions. So does the balance formula need to be in simplest form? Yeah, you usually put it in its simplest form. You don't ever put a 1 in a balanced equation. If you want to put 1 in front of your thing, you don't add it. You just leave it as it is, because lithium, say by itself, is implied it is just 1 lithium atom. You only ever put 2, 3, 4, etc. Never put 1 in front, as it is not needed. Okay, so let's try this example then. Some of you guys I can see have tried to attempt it in the chat, and most of you guys have got it correct, perfect. So yeah, let's start again with let's see how many atoms we have on either side of the equation. So Li, let's see. We have 1 lithium on this side, 1 lithium on that side. What about oxygen? As we know, O2, little 2 means 2 oxygen atoms. So therefore we have 2 there, but we have just 1 here. So we're going to have to balance this equation. So first thing to do is balance our oxygens, right? So if we have 2 oxygens on this side, we must get 2 oxygens on this side. How will we get 2 oxygens on the right hand side? We just need to add a 2 in front of our lithium oxide. So now if we see how many atoms we have on either side, we're going to get 2 oxygens on the right hand side and 2 on our right and left. So now the lithium is happy. However, if we look at how many oxygens we have on our right hand side now, we see that it's gone up to 2. And now, is 1 balanced with 2? No, it's not. Okay, so we need to now fix the left hand side. How can we get to 2 lithiums? We just put a 2 in front of the Li, and it is happy. So this is a balanced equation. I think that's our last example. So now we're going to move on to the... So let me look for the questions. In the question box, could you guys please just leave that for writing questions and not writing anything else? It would be very helpful. So there's not really much. Brilliant. So can you add powers? So powers isn't a thing in chemical equations. I don't really understand what you mean. So this thing at the bottom is not a power. Oh, we do have an example. So these are not powers. They're just, that's just how you write a chemical equation. So this bottom number tells you how many of the atoms you have in your formula. So in front of the atoms, will there always be 2 or 3? Not necessarily. You can always also, yeah, well, it won't be a 1. If it's just a 1, you just leave it blank. You don't add a 1. But otherwise it could be 4, it could be 5. You probably won't get examples like that in the GCSE syllabus, but usually it is 2 or 3 in front of the atoms or molecules. So oxygen, yeah, it always comes as a pair, never by itself. It's always O2. This probably will come up in your mocks in November, as this is like general to all questions. Balancing chemical equations comes off very commonly. So when balancing equations, great question, which compound should you start off with? So sometimes, like we saw in the other example, you can see that at first, without, if we just ignore the number, if we just ignore the numbers we put, we start by counting up counting the atoms on either side. So we start by seeing that there's 1 lithium here, 2 oxygens here, 1, 1, and identifying the atoms that are not balanced. That's how we start. So we start by balancing the atoms that are not balanced. So if we have the oxygen not balanced and we have 2 on the left hand side, we think, how are we going to get to 2 oxygens on the right hand side to make sure that that's balanced? So then we just think and we add the 2 in front of the lithium oxide, and then we go and recheck what we have on either side of our equation. So once you've balanced one of them, you need to always go back and redo this whole process, okay, of counting your atoms, just to double check. So we go back, count. On the left hand side we have 1 of the lithiums, we have 2 oxygens. On the right hand side we now have 2 lithiums and 2 oxygens. So the oxygen's now happy, however the lithium's now unhappy. So then you go to the unbalanced atom, look at it and figure out how to balance it. So now we know that we put the 2 in front of the lithium, and then we just check it. So now we have 2 in the front, 2 lithiums on the left, and then 2 also on the right, and then you're happy. Okay, so I think we should move on to the next topic of separation, but you have a chance to practice this. You'll have a chance to practice this in the Kahoot quiz. And also another question was, why don't we put the 2 after the oxygen? So do you mean here? I think that's what they mean. So why wouldn't we make LiO2 like this? So LiO is your compound, okay? So your compound never changes composition. Okay, so this formula, it tells you what your compound is. LiO doesn't change, but by putting a 2 at the oxygen, what you're now telling it is that your compound is Li with 2 oxygens. So like there's a 2 oxygens on either side. Whilst that's not your compound is just LiO. So when you put the 2 in front of the LiO, it's keeping the same compound, it's just multiplying the compound by 2. Instead of having 1 LiO, you actually have 2 LiOs. And therefore, that's why you have the 2 oxygens on that side. Yeah, so we're going to move on to mixtures and compounds now. So the difference between mixtures and compounds. So a compound, as we can read off the side, they have fixed compositions. What this means is, let's take salt, for example. Maybe many of you guys have heard it, know the compound, NaCl. This means that the ratio of Na to Cl is 1:1. This composition does not change. It's never going to be NaCl2. Okay, so compounds, they always have the same composition. They also need to be separated by a chemical reaction. You can't separate them by physical methods that we're going to cover next. And there are chemical bonds between the atoms of different elements. Okay, so the chemical bonds is what needs to be broken when separating. That's why you need a chemical reaction to separate these compounds. Whilst with mixtures, there's no fixed composition. So if you said you had a mixture of sand and water, if that's your sand and say this is your water, you can have a mixture like that. But another mixture could be with a tiny amount of sand just on the bottom and loads of water. So your mixtures don't have a fixed composition. The amount in it can change easily. So to separate this mixture, it's a lot easier, as you just need to use physical methods because there are no chemical bonds between the substances. They're just there mixed together. So what's really important to note is that in compounds, they have chemical bonds between the different elements. And to separate these compounds, you need to go through a chemical reaction. However, mixtures, they don't have chemical bonds between the different substances. And so you can separate them using physical methods, which we're now going to cover. So we're going to cover 3 today, and then tomorrow we're going to do some more on separating mixtures with a couple other methods. Okay, so physical methods. You may have done experiments on these at school, so you may be quite familiar with them, but you also may have never seen them. So filtration. This removes anything insoluble from a solvent. So your common example with that is, say, separating sand and water. So you have loads of sand in the bottom. Obviously, as all of you guys probably have seen, sand does not dissolve in water. So you've got your solid particles in the solution, in the solvent. Okay, so crystallization. That's when you get a salt from your solution. So in your solution, if you guys have ever, say, added sugar to your tea, so sugar starts off as a solid, you put in your tea and obviously it just disappears. It has dissolved in your tea. So how would we separate this? How would we get this sugar back as a solid? So this is when you use crystallization. And what you do is you evaporate all of your liquid. If this is our little sugar, the sugar will be dissolved. But if we evaporate the whole liquid, we'll be left with our solid sugar at the bottom. So that's how you separate something that's dissolved in a solution. So sometimes, say if we had a salt in water, so we had salt in water, this is also dissolved. I'm sure many of you guys have seen salt dissolving water. If we want to get our solid, but also keep our water, we would distill it. This means that the solvent is evaporated, but then we condense it. So when we evaporate it, we turn it into gas. When we condense it, we turn it into liquid, and then we keep this solvent and collect it. Okay. Okay. So next bit, let's talk about detail how these work. So hopefully many of you guys have done a filtration experiment at school. And you should have seen an apparatus set up similar to this, maybe. So here we have a mix of sand, salt and water. So the salt solution, we obviously have our salt dissolved in the water, so that's why you can't see any solid, but the sand obviously does not dissolve in the water. So what happens is we add filter paper to a filter funnel. So here you can sort of see there's some filter paper. We place it in our filter funnel and we put our contents of our beaker, pour it into our filter paper, into our funnel. So what happens is that the solid, the undissolved solid, it's caught by the filter paper. It can't pass through the filter paper. So all that goes through is our solution. In this case, our salt solution. So we have NaCl, salt, which is a solid, dissolved in our water. Okay, so that's filtration. So crystallization. So now this is kind of a process. This is separating salt, sand and water. Different ways to do that. So now we've got our salt solution here in a beaker. And what we do is we start heating it up. So we heat this up, which causes the water to evaporate. Okay, so the water evaporates and what you're left behind is with just your solid crystals. So you've removed all the water by evaporating it, and then obviously you just end up with your solid. So lastly, what is distillation? So this one's a bit more complicated. So once again, we're looking at a salt solution. It's sort of similar to our crystallization. However, in this case, we will be keeping our water. So we get our pure water out. So this is obviously a mixture, it's not pure water, and we're going to collect just pure water. So what happens is, once again, we heat it and it evaporates, yeah? So when we go through this part of it, it condenses. So therefore, the gas, so steam, it condenses and turns back into water, doesn't it? That's what condenser does. So how a condenser works is that you put cold water in from the bottom here, and then we get the water out. And in this thing, you're cooling down the steam and making water liquid, like you're putting the gas back to liquid state. Okay, and those are your 3 physical methods of separation. That we've already done that in the question. Okay, so now it's time for our Kahoot then. If people want to, wait, let me just quickly look at the chats if there's any. So a question, good question. So why do you need filter paper? So the way that it works, so if we look at this, if we didn't have filter paper, the opening of the funnel is too big, so it would let all the sand go through. Therefore, funnels, they don't separate the solid. The filter paper is what catches the solid, and the filter paper allows just liquid to go through, just solution to go through, because obviously in our solution we have the salt that is dissolved. So that's why filter paper is really important, to catch the insoluble particles. Okay. So tomorrow we're going to be covering fractional distillation to understand that. So what's the difference between a compound and a molecule? Good question. So a molecule is a compound. All molecules are compounds. That's just, they're basically the same thing. Let's see if there's any question. Yeah, so someone asked if CO2 means there's 2 carbons, 2 oxygens. So CO2 means there is 1 carbon, but 2 oxygens, okay? So if you don't have this little number next to your atom, it just means there's one of that type of atoms. So if, say, you had potassium chloride, that means we have 1 potassium and 1 chloride. If, say, we had magnesium chloride, so magnesium, MgCl2 is our chemical formula, we have 1 magnesium and 2 chlorines, because we have this little 2 next to the chlorine, okay? So another question is, does 2 LiO mean that there's 2 lithiums and 2 oxygens, or just 2 lithiums. So whenever it's in front of your chemical formula, you multiply the number of each atom by whatever's in the front. So it would be 2 lithiums and 2 oxygens. Perfect, whoever said that. So it multiplies it, and if in this case we had a 2 in front of the magnesium chloride, because in our normal compound we have 1 magnesium, 2 chlorines, and now we're multiplying each of those by 2. So we end up with 2 magnesiums and 4 chlorines. Hopefully that explains it. Yeah, so putting numbers in front is very similar to factorizing. You can definitely explain it to yourself using that. Sorry. What is a solvent? So a solvent is something that something's dissolved in. So for example, you have a water and a chlorine and sodium chloride solution. So water and salt. The solvent is water because your solid salt has dissolved in that. So how does the water get in distillation? Let's look at our distillation apparatus. So as we can see, so what happens is the water evaporates, it then reaches this part and it follows this tube down. So that's how it reaches this part. So it just, because the water is now a gas as it's evaporated, it can just move through this, and then it reaches the condenser where it obviously goes back to liquid water, no longer a gas. So we use filter paper as otherwise your solid will just run through the funnel. The filter paper is what catches your solid. Okay, and then so in distillation, the salt would just remain in this beaker. So the salt would just be left over here as a solid. Yeah, so you can't touch the little number. You only change the number in front of the whole thing. Brilliant. Great insight. So halogens do always come in a pair. So they do always have 2s next to it on the right. So halogens are always in pairs. So this is simple distillation, it's not fractional distillation. And water isn't added in simple distillation, that's just the solvent. So that's what the salt has been dissolved in. So in the condenser, so the way the experiment works is you just connect the condenser to your tap at school, and you just put the tap on and it runs through the whole thing and out the top. No, the condenser just needs to be below the boiling point of water. Okay, so I think it's going to be time to start the Kahoot, and then we'll just cover any other questions that we get. So let's go to Kahoot. So if people don't have a way to access this, just write it down on a piece of paper, and at the end we're going to go through the answers. Okay, so let's start then. Sorry, let me just turn off the music. Okay, so I'll give it a few minutes, well, a minute or so, to get up to the people. Oops, sorry, I think I just started the game by accident. Did enough people join in? If people haven't. Just put, if you haven't been able to log in, just put your answers down on a piece of paper, and we'll just do it like that. So we keep, and then at the end you're going to be able to see if but you can try again. Try join the game now. Whoever's not been able to join it, try entering the game pin again, and you should be able to join it now. Yeah. Okay, brilliant. Well done to everyone. We'll go through why it is 120, why it's the blue one after the game. Okay, well done, Tigger. Okay, question 2 then. How many neutrons are in aluminium? So here, look at the provided with the element from the periodic table. So if you just, whenever everyone's answered, I think it's just going to move to the next question. So you want to put in an answer. Okay, 10 seconds left. Well done. So well done to 100 of you. And we're going to go through the answers soon. Well done, Niraj. Okay, next one. Question 3. What's the charge of relative mass of an electron? So which one is it? Well done, keep the answers coming in. And then done a bit early, it should skip on. And please write down your answers if you can't access it. Okay, 10 seconds left. And then 2 more questions and we'll go through these answers. Okay. Ooh, so this one maybe we struggled slightly on. I'll cover it quickly afterwards. Well done to everyone. Well done to leaderboard. Okay, so now this was a balancing equation one. How are we going to balance this equation then? Okay, 30 seconds left. Okay, then almost there. Last 10 seconds. Well done. That's really good. Great effort. Oh, well done. The dot stayed at the top. And then the last question. How do you separate sugar from water? Okay, half minute left. Okay, keep the quick answers coming through. Doing great, well done everyone. Okay. Okay, brilliant. So see, both these were correct, as we'll go through now. Okay, well done to everyone. See what the podium says. Oh, well done to you three. Congratulations for getting on the podium. Okay, so let's go quickly through the answers for this and then do any other questions that people may have. Okay, so question one. What was question one? So question one, how many electrons are in silicon? Okay, so electrons in silicon. So now we look at the proton number at the bottom. It tells us it's 14, and we know that the proton number is equal to the number of electrons, so therefore we know it is 14 electrons as well. Okay, next one. Oh, sorry. So how many neutrons were in aluminium? So we know that the bottom number, like we said, was the proton number, so that's number of P. We know from before that the mass number tells us the number of P and N. Therefore, if we do 27 minus 13, we're going to get our number of neutrons as 14. That's why the answer is 14. So what is the charge and relative mass of a... What is the charge and the relative mass of an electron? Okay, so the relative charge is -1, and the relative mass is 1/2000. Or you can remember it as 0. Either of them is correct. This is just a bit of a fact. Okay, next one. So balance the equation. Like we've seen previously, we're going to think about how many hydrogens we have on the left, and how many hydrogens we have on the right, and how many chlorines we have on the left, and how many chlorines we have on the right. So H2 means the little 2 is telling us that we've got 2 hydrogens, so we put 2 for hydrogen. Cl2, the little 2 is telling us that we have 2 chlorines. And then on the left-hand side, in the formula, it's telling us we've got 1 hydrogen and 1 chlorine. Therefore, to balance it, obviously, on the right-hand side, we're going to need 2 hydrogens and 2 chlorines. So if we just put a big 2 in front of the HCl, we're going to see that it's now balanced. So big 2 means that we have now 2 times 1, because we've only got 1 hydrogen in our formula, so that means 2 hydrogens and 2 chlorines, because also 2 times 1. Okay, and that was your answer. And lastly, how would we separate sugar from water? So obviously we start with sugar as a solid form, and then we've dissolved it in our water to just get a colourless solution. So filtration wouldn't work for this, as we don't have any solid left over. So obviously with filtration, we're separating solid from a solution, or from a liquid. Yeah, but now we need to get the sugar out of the water. So therefore, either we're going to crystallize and just evaporate the water, or we're going to distill it, once again evaporate the water, and then collect it in another beaker. Okay, so that is the solutions. Okay, so I've got a couple minutes left, so I'll just keep going through the questions asked. And if we run out of time because we don't have very long left, you can always ask your questions tomorrow, as we have another session for the rest of this week anyway. So with the state symbols, when do we use them? You will be asked in the question explicitly saying, please include state symbols. So if, say, you were asked to do, oh no, that's not a good one. If you say we're asked to do H2O plus O2 goes to water, as we've seen, the balanced version is 2 in front of there and 2 in front of there. So the question will say, well, the question will give you this, and it will say, please balance this equation and include state symbols. So then you need to know to put that hydrogen is a gas, oxygen is also a gas, and that H2O is a liquid. So you'd know to include it. The question will tell you to include it. Yeah, so a salt solution is a mixture because the salt is not chemically bonded to the water. So it's just in the water, it's just floating about. It's not chemically bonded. There's no bonds. So that's the big difference between a mixture and a compound. So in compounds, the substances, well, the atoms are chemically bonded, whilst in mixtures, there's no chemical bonds involved. So how do you square an element? You don't ever square an element. That's not a thing. Squaring is just for maths. There's no such thing as squaring an element. So I'm just trying to skim through all the questions. So to finish off, we'll quickly go through balancing an equation. So we'll go through this one again because people seem to have a common issue with this one. So let's start. We're going to once again count the number of atoms of each different atom we have on the left and on the right. So if we look Fe here, oxygen and carbon. So those are the 3 different atoms we have in our equation. So then how many ions do we have on the left? We have 2. How many oxygens do we have? So this little 3 is telling us we have 3 oxygens in this formula and just 1 oxygen in the other compound. So therefore we've got 4 oxygens in total. How many carbons do we have? We only have 1 carbon on the left hand side. Okay, so now let's count on the right hand side our atoms. So we have 1 ion on the right, 1 carbon and 2 oxygens indicated by this, 2 oxygens and then 1 carbon indicated. So the 2 oxygens is indicated by this little 2. Okay, so let's start. We can see that neither the ion or the oxygen is currently balanced. Not 4. So now let's start with the oxygen. If we balance the oxygen, we're going to put a 2 in front of this one. Yeah. So now we need to go back and check our carbon and our oxygen atom. We need to count up how many we have on either side. So now on this side, we have 4 still oxygens, as we haven't changed that. And on this side, we have now 4 oxygens. So the oxygens are happy. However, now we've gone to 2 carbons. So the carbons are now not happy. Yeah, so now we're going to have to somehow find a way to balance our carbons. So we're going to put a 2 in front of this. So now we're going to have a change in number in carbons and oxygens on the left hand side. So we're going to get 2 more oxygens. So now we're going to have 5 oxygens on the left hand side, and we're going to have 2 carbons. So now the carbons are balanced, but the oxygens are not balanced again. So now we're going to try balance our iron. So we're going to just put a 2 in front of the iron, and that's going to give us 2 ions. So that's happy. However, we're going to have to go back and try fix these oxygens. Dun, dun, dun. So now, if we put if we put 2 in front of this one. Okay. So, do any of you guys have any ideas? Okay, so I feel maybe we should leave it here and revisit this one next lesson, as I think we're going to run over significantly, as this one has quite a lot of steps to it. Yeah, so we can start with this next lesson. So tomorrow we will balance this one. Okay, so let's finish here then. Lovely to meet you all, and hopefully see you tomorrow.